two columns of 3, right? Yeah? Roughly, yeah, so it's something like this, right? It's 2 plus 3 plus 4. So we can either add the yellow to the, which color is this? Pink? Okay, we'll agree with pink. So yellow plus pink and then add blue, or first add pink and blue and then add yellow. The number of biscuits are not going to change, it's going to stay the same because biscuits do not. G.
If you have an option to change the position of the numbers, then you can
use the commutative law.
Plus.
Yeah, to you be correct. That's a commutative law. You will also combine the commutative law. Yeah, that's the associative law of addition. What about the associative law of multiplication?
A into B into C equals A.
You guys are very. I use numbers. You use algebra, which is fine. Yes. But why is that true? So take a simple example. So let's take a simple example. 2 into 3 into 4. Why is that equal to 2 into 3 into 4? G.
So if there are two boxes, each containing
Two boxes. Let me make two boxes. You can see I was deprived in art as a child, so I like drawing. Two boxes. G.
each containing three containers.
3 containers. There you go. 3 containers.
And each container has 4 cookies inside.
4 cookies inside. Okay, that's good. So we have 4 cookies inside each container. Here you go. Okay, so now we have 4 cookies inside each container. G.
And you count all the cookies.
How? So what's the left hand side? What's the right hand side?
So,
In the left hand side, we're counting what first?
so on the left hand side, we have to count the total containers inside the box.
Yeah, we are counting the. So this is, what do you call this? This is called a. ये क्या था? आपके 2 क्या थे? Boxes थे. So these are boxes. These were containers. Okay, these are containers, and the inside are cookies. So you're on the left hand side, you're counting the containers first, the total number of containers in 2 boxes. So there are 2 3s, 1 3 and another 3. So you have 2 3s, which are the number of containers. And then inside each container, so there are 6 containers, and inside each container are 4 cookies. That's why that's the left hand side. What are you counting on the right hand side?
So
What is 3 4s?
So 3 fours, there are 3 containers in a box. There are 3 containers, and each container contains 4 cookies.
So you are counting the number of cookies in one box. That's what you're doing, right? So 3 4s are the number of cookies in one box because each box contains 3 containers. So 3 4s are 12, and that's the number of cookies in a box. And then you have 2 boxes. That's why you have 2 3 4s. Okay? Is this clear? Yeah? All clear? Good. Okay. What about the such associative law? What's the distributive law? Ji bete. No, first write down the law and then we'll. So what do I write down here? Yeah. What numbers, multiplying, adding, what do I do?
A into B split into A plus C into B.
एक सेंस है ऐसा बोल रहे हैं A. So I'm going to put A की जगह 2. Okay. 2 into 5. बस 2 into 5.
Yes, sir. In the book.
You never. So my suggestion is, when you're talking mathematics, so just say what is. Don't say, sir, you said, or the book said. You are saying it. So it's you who's talking. Ji, go ahead.
7 into 7 into 5.
2 into 7 into 5?
7 into 5 into
7 into 5. Okay. So 7 into 5 is 7 5s, G, which is 35.
2 plus 3.
7 into 2 plus 3. So I have to write down. So I'm going to write down 7 into 2 plus 3 is equal to 7
Into 2.
plus 7 into 3. Yeah. So 7 is a big number. That's fine. We'll have to deal with it. Okay. So now tell me a story that convinces me it's true.
Two boys having 7 cookies and 3 girls having 7 cookies.
Okay. So yeah. So this is how you would start. Okay. There are 2 boys. So there are 5 children. There are 2 of them are boys. 3 of them are girls. Each one of the children has 7 cookies. How many cookies are there in total? So one way to count is count the total number of children, and then you count the total number and you multiply by the number of cookies. So you have these, although you have 7 5s. So I'm sorry, that's not a good statement. So you have 7 children. Where do you have 7 children? 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 children. Each one of them has 2 chocolate cookies and 3 strawberry cookies. Okay? बात समझ आ रही है आपको? क्योंकि वहाँ पे there were 5 children with, so I should have written, अगर जो आपकी story थी ना, that would have been better with this representation. Do you understand that why? Because there were 2 children with 7 cookies and 3 children with 7 cookies, right? Do you understand that? So it was 2 7s. The boys had 2 7 cookies and the girls had 3 7 cookies. So the total was whatever, 35 cookies. यहाँ पे the story would be, there are 7 children and we don't care about the gender. They have 2 chocolate cookies in their pockets. You can't keep cookies in your pockets, in their lunch boxes. And 3 strawberry cookies in their lunch boxes. So how many total cookies do they have? One way is to add the number of chocolate cookies to the number of strawberry cookies. You have 5 cookies, 7 5s are 35. That's one way of doing it. You have 7 5s. Another way to think about it is count the number of chocolate cookies first and then count the number of strawberry cookies and add them together. And unless your friend starts to eat your cookies, cookies do not in general disappear, right? So that's why the number of cookies does not change. Agreed? Yeah? Good? Okay. So that's the distributive law. All good? और मैंने आपको कहा था कि associative law का बहुत सारे लोगों ने मुझे last time suggest किया था, although I don't have a nice drawing, but I'll take my liberty and try to draw using my artistic skills. You can see I'm eventually going to become an art teacher, right? Okay, so this is going to be a cuboid. Okay, I wanted you to look at it. I asked you to, so this is supposed to be a cuboid, okay? And this has length 4. And then this would have length maybe, okay, this is a bad representation. Let me make it a bit shorter. So here, okay, let's make it a bit shorter. So here, okay. So this is going to be 4. It is not to scale. I apologize for it not being to scale, but these are the dimensions of this. So what that means is, remember, if I have a 2 by 3 thing, here's a 2 by 3. Let's just look at 2 by 3. What it means is I have these number of squares. Is this clear? This is a 2 by 3 rectangle. So imagine a Rubik's cuboid. तो इस पे आपको you will see, अगर मैं इस side पे देखूं, so you will see a line like this and you will see 4 such lines. Is this clear? ये बात समझ आ रही है? On the front face. Is this clear to everybody? Yeah? नहीं? Sorry, I'm going to grab your book. So just maybe 1 second, right? So अगर ये dimension is 4, this dimension is 2 and this dimension is 3. So what does it mean? It means there are 3 squares इस तरह and there are 4 squares this way. So how many squares will be on top of this surface? Yeah, 3 4s, 12 यहाँ पे होंगे. If this dimension is 2, the smaller dimension is 2 and this medium dimension is 3, how many squares will you see on this side? 6. Is this clear? Yeah? आपको बेटे समझ आ रही है? Sure? Okay. So now, thank you. So यहाँ पे what that means is there are various ways of counting, right? So एक तरीका है, I'm counting the number of cubes, little cubes. So that's another way to think about it, right? So now look, if I look from this side, अगर आप top surface पे देखेंगे, I think I will borrow your book again. So अगर आप इसकी top surface पे देखेंगे, So remember, this dimension is 4 and this dimension is 3. So how many cuboids are you going to see on this surface? 3 into 4, 12, right? And remember, there are 2 layers of these 12 because there is one layer on top and there is one layer at the bottom. Is this clear to everybody? Ji.
Will there be cuboids on the top layer or
Cubes. There will be cubes because they are all of dimension 1. Side 1 ke sare hain. Right? Because that's why so I am always considering of a small cube which is of dimension always 1. So 1 cubed, or in cubes को आपने देखा हुआ है Rubik's cube में कि there are little cubes that you fit in to make a bigger 8 by 8 cube. But I am thinking of not like an 8 by 8 by 8 cube. I am thinking of a cuboid which is 2 by 3 by 4. Okay? And you can look at it online if you wanted to. So there will be 12 on the top surface and 12 on the bottom surface. So that means 2 3/4. Is this clear? That's the numbers on, agar main is tarah count karna shuru kuru layer by layer. But there's another way to count. What layer am I talking about here? Kis tarah main le raha hu section? So yeah, so I am counting, main यूं chop कर रहा हूँ इसको. Okay? Yeah, 2 3s are chopping it up this way. I'm looking at it. अगर मैं इस layer को देखूँ, so this dimension is 2 and this dimension is 3. So इस layer पे how many cuboids will I see? 6. And there are 4 such layers. Remember, there are 4. 1, 2, 3, 4. So there are 4 such layers. So 2 3s and I'm multiplying it by 4 times. Is this clear? Okay. Sorry, okay. So you have to look at it. So because of my beautiful drawing, it is hard to exactly understand. What part you did not understand, and then I'll refer you to looking at a physical Rubik's cuboid and counting. लेकिन अभी आप मुझे बताएं आप क्या कह रहे हैं?
Sir, when you said the 2 that part I understand how you presented it.
Sorry, दोबारा बोलिए.
So when you said 2 3 4, the representation which you did on that cuboid, I didn't understand that.
Both sides?
Yeah.
ना ये वाली side, ना ये वाली side.
Oh, the first side.
This side?
Yes.
Okay. So let's look at a side. So let's look at it. So maybe you're pointing to something which is slightly a bit something. So I'm going to assume, so very explicitly, I'm going to assume the commutative law of multiplication. Okay. Now let's look at 2 3s. What are 2 3s? So 2 3s are going to be the number of cubes in this layer. Is this clear or not clear? Yeah? 2 3s are the number of cubes in this layer. If it were to say, अगर मैं इसको equivalently 4 2 3s लिख दूँ. So do you see 4 2 3s? There's 1 2 3, there's another 2 3, there's another 2 3, and there's another 2 3. So there are 4 2 3s. Yes or no? So 4 2 3s are the same as 2 3 4s. So I've used the commutative law to say this is equal. Does that clarify your question? Yeah? Sure? So I actually showed you, you correctly pointed out, I showed you 4 2 3s, but I wrote 2 3 4s. And I'm using the commutative law to convince you that this is true. Yeah? Your eyes don't seem to suggest that you have understood. Okay? So muse about it. Aur na samajh aaye to come back and ask. Look at a physical picture. Any other questions? Okay. Now, we quickly also, I mean, the point of doing all of this is to convince you that there are reasons. Okay? It's not arbitrary. Arbitrary is like the sign of plus or minus. That's arbitrary. But there are things which are definite, like the commutative law is something which is very inherent and cannot be made arbitrary. Okay? Now, remember that the most important thing, beta ye please class mein na kare, okay? It disturbs the class drink afterwards because you're not talking all the time, okay? So do not drink in the middle of the class. Thanks. Okay. So now, a very important thing is कि place value को हमारे long addition, long subtraction, long multiplication and long division algorithms make things come alive. Otherwise, if we couldn't calculate, हम बहुत तारीफ करते हैं कि place value वाह 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 बहुत अच्छा तरीका to represent numbers, but if you couldn't do anything with it, it would be kind of useless, right? Because, so okay, so I can give you a picture, like so here's an example. Here's a beautiful looking car, okay, amazing car. बहुत आप देखने में करते हैं कि wow, it's going to go very fast, it's going to be very efficient, right? All those things. But it can't move, right? So what do you do with that car? It's a useless car. It may look beautiful, but it doesn't do anything for you. The car has to go from point A to point B. If it can't go from point A to point B, it's a useless car. Ji.
So you said it's very fast.
It was theoretically very fast if it could move, but it would never start. So that's why it's kind of a useless. I'm just pointing out that by the only reason why something is useful, like when we really say it's amazing, is because it can be used in a very effective way. And the way that the place value number system can be used very effectively is because of the long addition, subtraction, multiplication, division algorithms that have been developed. Okay, that's the critical part of it. So now the question was, कि मैंने आपसे ये सवाल पूछा था कि why do these algorithms work? So did anybody think about it? Why do these algorithms work? Do you have any ideas? Okay, let's try. Did anybody else think about it? Okay, let's try this. 239 minus 189. I'm sure all of you will be able to do this, something like this, right? That's the answer. I'm just using in base 10, right? This is what you know. Let's write it out and see what do we actually mean by this. So let's try to write it out here and see, okay, what do I mean? Maybe I shouldn't write it here, maybe I should. So we have, let me just do this here. So this is going to be 2 into 10 raised to the power 2. Is everybody comfortable with the notation, power notation?
Yes.
Everybody knows it? Okay. 2 into 10 raised to the power 2 plus 0 into 10 raised to the power 1 plus 3 into 10 raised to the power 0 minus parentheses mein 1 into 10 raised to the power 2 plus 8 into 10 raised to the power 1 plus 9 into 10 raised to the power 0. Right? Same thing? किसी को कोई एतराज़ अभी तक? All good? Okay. Now, remember, if I have apples, so you have 5 apples. Can you eat 4 oranges? You have 5 apples lying in front of you. Can you eat 4 oranges?
So we can get a bit of the fridge.
Sorry?
So we can
No, you have just 5 apples. No oranges at home. 5 apples. You want to eat 4 oranges.
So we get a way which converts apples to oranges.
No, there's no way to go. So you can only eat apples. If you have apples, you can only eat apples, right?
Unless you name the
Yes. But then the name of the apples changes into oranges and then you still don't, then you can eat oranges but then you can't eat apples, right? So whatever, okay. So the point is, okay, I want to eat away, that's what I want to do. I want to eat away a 10. I want to eat away, 100. I want to eat away an 8. I want to eat 8 tens and I want to eat 9 units. That's what I want to do. Is this clear? Because I'm subtracting is eating away. So I have, think about it, right? I want to eat 100, 8 tens and 9 units, right? Is this clear? Right? So now, if I want to eat 9 units, I only have 3 units. I can't eat them, right? So there's no way. So the way I will eat it is that I will rewrite it, and maybe you will start to see this. I am going to do this. I am going to rewrite this as Is this clear to everybody what happened? What I did was I took 100, broke it up into 10 tens. So I had 10 tens. 100 is 10 tens, everybody agrees? So I took 100, broke it up into 10 tens, left 9 tens over here, took a 10, broke it up into 10 units and added the 10 units to this number to get 13 units. Is this clear what happened? Ask the question again if something is not clear. Sure. So I did it very quickly, but think about it. So here, this is a 100 rupee note. Okay, so imagine you have 100, so you have a 100 rupee note, you have no 10 rupee notes, and you have 3 1 rupee notes. Okay, you have 200 rupee notes, so here are 2 100 rupee notes, and you have 3 1 rupee notes, right? Okay, and now you have to give 9 1 rupee notes to somebody. I guess we don't have 1 rupee notes anymore, but whatever, right? Okay, so now how do we do it? We take 100 and break it up into 10 tens. So the 100 is going to disappear, and now, yeah, so we're going to get rid of the 100 and we're going to put in 10 tens. There are going to be 10 tens that are going to replace it. You have the same amount of money still, okay? But I still can't give 9 ones to somebody. So what do? I take a 10 and I replace it with 10 ones. So how many ones do I have right now? 10 plus 3, 13. That's what I wrote here, 13 ones. Is this clear? Then I had 10 tens, but I chose to convert a 10 into 10 ones. So how many tens are left now? 9 tens. 9 tens. And how many hundreds do I have? I had 2 hundreds, but I converted 1 into 10 tens. That's why I'm going to be left with 100. Is this clear? जी, आपका क्या सवाल है? Because 100 got converted into 10 tens, and then 110 out of those 10 tens got converted into 10 ones. 9 tens are left. Ji, is this clear? So now do you see what I did over here? 2 को काट के मैंने 1 किया था, 1 को मैंने पहले 10 किया था, मैंने इसको डिटेल नहीं लिखी, लेकिन 10 को काट के मैंने 9 में कन्वर्ट किया था, and then I took a 1 over here. Is this clear? This 1 actually represents 13 ones. It represents 10 ones and 1 3, that makes the number 13. Is this clear? Now do you see exactly this and this are exactly the same thing.
Sir, but if you put a 8 instead of 9,
कहाँ पे?
here.
Where? नहीं, यहाँ पे नहीं, मुझे यहाँ पे करना पड़ेगा चेंज. यहाँ पे क्या चेंज करूँ, फिर मैं वहाँ पे चेंज करूँगा, right? What change do you want over here?
2 instead of 1.
2 यहाँ पे?
No, over the 3.
Over the 3. If I put a 2 over here,
Yes.
then this will be a 2 and this will be a 2. That's the change that will
It will
happen.
become 23.
Why will it become 23? It's a 2. Where do you want me to write a 2? Instead of a 3?
If we write 1 multiplied by 10 raised to the power 2 plus 8
1 multiplied by 10 raised to the power 2.
plus 8 multiplied by 10 to the power 1.
Where are we right? मैं पहले इस question को change करें and then I'll worry about it. What change do you want in the... So then why are you... I am not trying to... There may be multiple ways of writing it. I am trying to show you what this algorithm is mathematically. I can write it as 100, 10 tens and 3 ones. I can write it in multiple ways, but that's not what is interesting. What is interesting is what will allow me to calculate quickly. So I'm trying to show you that the algorithm is correct mathematically. That's what I'm trying to show you. Ji.
Actually, he is trying to say we have taken 1 tens as carry with 3.
We took 110 G.
If we take,
We can take 5 tens.
we
it would be a waste of time. We could do that, but that does not show the correctness of the long subtraction algorithm. You're not following the long subtraction algorithm. That is what I was trying to tell him. The long subtraction algorithm is not, this is not what you do. Is that what you do? Do you carry 5 tens? पूछ रहा हूँ आपसे. Right. So I am trying to convince you that the long subtraction algorithm is correct. I'm not talking about any other algorithm. Okay? Does that answer your question? आपको बात समझ आई है? Okay. Ji, any other questions about this? So now you can see 13 minus 9 is 4. 9 minus 10 is going to be 1. 10, I'm using the distributive law of subtraction or something. And then 110 minus this is just 0. So this is the answer, which is 14. Okay? Now you should be able to see that the long subtraction algorithm is exactly this. इसमें और इसमें कोई फर्क नहीं है. Except this is much slower than this.
But you are giving us just one example.
Now you can generalize it to any example. That's a very good point. So whenever, okay, there are so many different cases, okay, but you can imagine what are we doing. Whenever we are subtracting, writing it out in general is very complex because the problem is going to be that there are so many cases, right? Pick another example. Give me another example. 183 minus what? 147, right? So now this is what we do.
Sir, but you said that if we give a few examples,
Yeah.
does it prove it?
Sure, but now what you can do is, okay, you go home and try to generalize it. There will always be two cases. Either you carry or you don't carry. So writing it will become painful. There is nothing magical about any number. That's what you will find out. So how about as a homework, I'll suggest, in fact, I'll ask you to write up the general case. And you can. It's not hard. It's just painful to write. So maybe you'll enjoy it. So that's not a bad idea. So here. So now, this is the most general 3-digit case. You could go to a larger digit case. It's going to be maybe P, Q, R. And now there are going to be cases, either you want to be carrying here or you will not be carrying here. So you'll have to worry about 2 cases in each thing. You'll have 8 different cases to write up. As a homework, you can write it up. Good? And it will be a most general proof. And if you're not satisfied with 3, then we can work with n, and that would be absolutely general. Ji. Yeah, so that's a good homework. After you do your homework, then you'll ask the next question. Ji. ठीक है, homework करने के बाद मुझसे बात कीजिएगा. No. Do you understand? First, do the 3-digit homework, and then, so this is a homework. Do this in the most general case. This is the most general case that you have to worry about. Do it in the 3-digit case, and then we'll talk about the n-digit case that will make it absolutely general. ठीक है? Okay. जी. यहाँ पे कोई question था. So now you can see that exactly the same thing is going to apply here, right? You're going to take the 8 tens and convert it into 7 tens and 10 ones, and the 10 ones will go over here to make 13 ones. 13 ones minus 7 ones will make 6 ones. The 7 tens minus the 4 tens will give you 3 tens, and then the hundreds, 100 minus 100 will give you 0 hundreds. So you can see it's exactly the same. There's nothing magical happening when you change a number. Okay, that's what is important to see. Okay, this is a long. Now you can also see that there was another question, why do you start from the left and not from the right? That was a question, right? No, it is a choice, but there's a smart choice and there's a silly choice, and I'll try to explain to you in a second, what's a smart choice and what's a silly choice. I'll show you in division. So now let's take an example, which is, in fact, Ji.
I have a problem.
What is the problem?
So,
What kind of problem are you talking about here?
we have 50 rupees.
Right.
Spent 20. Left,
Right. 30. Ji. फिर? Oh, this is not important, right? I mean, this is हम इसके बारे में बात. There's a little trick that you want to discuss. I'm talking about algorithms. You'll talk about the trick later on. There's a trick question that you want to get answered, right? Yeah. इसके बारे में we will talk about it in a second. It's okay. So the other thing that I want you to talk about is long addition and long division. For example, why do they start from opposite ends? So there's another idea, which is, let's try to think of 379 plus 480 addition, right? And now you can see 9 ones plus 2 ones gives you how many ones? 11 ones. And then 11 ones go, we convert it into 1 1 and 1 10, and we take a 10 and save it away. Then we add the tens, it's 7 tens plus 8 tens, which is 15 tens. 15 tens may we add a 10 to get 16 tens. We separate out the 16 tens into 6 tens and 10 tens. The 10 tens becomes 100, and then you take 100 and you add it to 300s and 400s to get 800s, and that's the answer, right? That's one way to do it. That's a long addition algorithm, and you can also see it proves the correctness of the long addition algorithm at the same time. But there's no reason that you must start from the left. From the right, let's start from the left. Okay, so here's 700s, here are 15 tens, and there are 11 units. Okay, I've started from the left. Is that okay? I have 700, 15 tens, and 11 units. That's a number. Agreed? कोई गलती की है मैंने? There were 300s and 400s, I got 700s. There were 7 tens and 8 tens, I got 15 tens. I got 9 ones and 2 ones, and I've got 11 ones. Agreed?
Sir, if they have 26 apples and they have to add 15 more into them, they will first take the physical things, and then they will do it from right and then from left, and they will then compare the answers.
I don't quite understand what you're saying. So hold on to thought. बाद में explain से बात कीजिए. I want to wrap this up. So hold on to this thought. Now you have 700s and 15 tens. So you have 15 tens. You have a lot of change. So what can you do with it? I'm going to start all this from the left. So 15 tens, I can convert it into 100 and 5 tens. Sure, I could do that. So I have 5 tens and 100 extra and 11 ones. That's completely kosher, right? But now I have 11 ones, so I can convert it into 10 and 1. So I'm going to get 08, 06, 01, and this is the number 861, which is exactly what you would have gotten in any other way. Is this clear? Same thing. It's just a bit longer. Do you see this? It's a bit more painful. Ji.
Sir, but if you solve it from left to right,
Right.
no need to convert it.
The reason why you want to convert it is because in place value, when we work in place value, you always, as soon as you get to 10 hundreds, you do not write. So you see, when you have a number x, y, z, the assumption is this is between 0 and 9. So if I have a number which is bigger than 9, then I want to move it into the tens place. That's the assumption in place value. So मैंने यहाँ पे violate की थी, that's why I put commas here, because that's not how you usually write place value. And you can see from here to here, when I went, I got rid of the commas and said now I'm writing in place value. This was no longer in place value. This was in place value, not in place value, not in place value, not in place value, back to place value. So if we violate place value, there's nothing problematic about going in addition from left to right or from right to left. There's nothing wrong with it. But it's inconvenient. It slows you down. Remember, the long algorithms are meant to make you quick, not to make you slow. ये बात समझ आ रही है आपको? So it slows you down. If somebody says कि mathematics terrible things will happen to mathematics if you start the algorithm from the left or the right, नहीं होगा. It will just slow calculations down. And who wants to slow down calculations, right? You want to do calculations quickly. That's the reason why you do it. Similarly, look at addition. I'm also trying to convince you that these algorithms are correct. Okay, first let's do it in the usual way. So how many hundreds do you have?
So we have 800.
800s, right? 800s. And there are 7 kids. How many hundreds will each kid get? 1. 100 every kid will get, and you will be left with 100, right? Okay, you are left with 100. Now you are left with 100 and 8 tens. So what do? I have 8 tens, which are these, and 100. So what do I do with 100?
So
I convert it into a
tens.
How many tens?
10
10 tens. So I convert 100 into 10 tens and I take my 8 tens to get how many tens? 18 tens. So these are tens. I have 18 tens now, right? I have 18 tens and 7 children. How many tens will each child get? 2. So 2 sevens are 14. So now I'm done. So remember, I can only subtract apples from apples and oranges from oranges. So I'm subtracting 14 tens from 18 tens to get how many tens? 4 tens. Now 4 tens are मेरे पास and I have 9 ones. So what do I do with the 4 tens? Excellent, Arjun. Ji, what do I do with the 4 tens?
So we will bring 9.
नहीं bring नहीं, मुझे कहानी बताएं. 4 tens के साथ मैं क्या करूँ?
Then we will convert 4 tens into 9 units.
Units. To get how many units?
49.
40 units, and then 9 units we'll add to get 49 ones or 49 units. So now I have 49 units, and now I can give 7 units to each to get. So that's 127 to each child, right? That's the correctness of the long division algorithm also, but also the way it works. But now you can think of it in a different way. Yeah. So now I'm not going to do it from the left. I'm going to do it from the right. Okay, I'm silly. I want to do it from the right. So let's do it from the right. So here's, I have 9 ones and I have 7 children. I have 9 ones, right? I have 9 ones over there. 889, I have 9 ones. I want to give each child something. There's 7 kids. How many ones can I give to each child? 1. So I'm going to give 1 to each child and I'm going to get a remainder of 2. Can't do much with it. Okay. I have 8 tens and I want to give 7 to 7 children. I'm going to get a remainder of 1. So these are ones, these are tens, and these are hundreds. Okay, so I have 8 hundreds and I divide and I get this. Now I have 100 left. Remember, they're not the same. So I should have maybe used, so this is, remember, a 100. This is a 10 and this is a 1. Okay, 1s hai. So now I have a 100 rupee note, a 10 rupee note, and two 1 rupee notes, right? So now what do? Well, I could make a choice. I am being silly. I could take a 1 10 rupee note and convert it into how many ones? 10 ones. So I'll have 12 ones. I have 12 ones, and how many can I give to each child? 1. So I convert these two. And now I'm going to be left with, so ये मैंने सब कुछ बच्चों को दे दिया हुआ है, remember? So I gave this to, this has been given to each child. Now I'm going to take a 12, and I'm going to be left with 1, remainder 5. So I am going to give this to each child as well, and I'm going to have 5 ones left. Is this clear? 5 ones are left. नहीं? एक 10 था, एक 2 था. कितने हुए वंस मेरे पास टोटल? 12 वंस. 12 वंस मैंने 7 बच्चों में तकसीम करने हैं. How many will each child get? 1 to each child and 5 will be remaining. So हर बच्चे को 1 मिल गया, remainder 5 बच गया. Clear?
Yes.
Yeah? Okay. So now अब मेरे पास total remaining क्या पड़ा हुआ है?
So 5 and 100.
5 and 100. Is this clear? So now I have 100 और मैं 100 है मेरे पास और 5 ones हैं. Okay? So since I'm silly, I'm going to take 100 and convert it to 10 tens. I'm being stupid in any way that I want to. So अगर मेरे पास 10 tens हो, तो how do I divide into 7 children? 1 10, and I'm going to be left with a remainder of 3. So अब मेरे पास 3 tens बच गए और 5 ones बच गए, right? So the only thing that's left is I convert the tens into ones. So I'm going to be left with 35 ones, right? 3 ye or 5 ye, right? So 3 tens plus 5 ones will make 35. 35 divided by 7 is going to be equal to 5. So what did I give to each child? Well, I gave, एक सेकेंड, एक मैंने 100 दिया, 110 दिया, 1 ये दिया, 1 ये दिया, और एक 10 दिया और एक 5 दिया, right? Okay, so what did I give? 127. पता नहीं, you are very fast. 100, 110 here, 110 here, so 120, and 1 here, 1 here, and 1 here. 127. I got the right answer. Right? Now which way method would you prefer? Oh वाला, right? Is this clear? लेकिन it works. This is what I'm trying to tell you कि गलत नहीं है. कोई ये नहीं कह सकता कि this is wrong, because division is division. बात समझ आ रही है आपको? लेकिन is it effective is the question. हम algorithm की we want the algorithms to be fast. This is blazingly fast. This is very slow because this was blazingly slow, right? I mean painfully slow. कर सकते हैं, कर सब कुछ सकते हैं, गलत मैथमेटिक्स नहीं है, लेकिन स्लो मैथमेटिक्स है, दैट्स ऑल. ओके, इज दिस क्लियर? ओके जी जी
इसके साथ कैलकुलेशन करते हुए जिंदगी में है लेकिन कल्पना.
ओके जी 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 ओके, वेरी गुड. सो दिस इज सो नाउ the major thing that you need to learn. Okay, so what's the moral? पहले हमने lectures काफ़ी, I mean I've spent a lot of time on these algorithms जो primary school के थे. I'm going to sort of start speeding up slightly. लेकिन इनका क्या मकसद क्या है? What's the moral of the story? Like tell me a line just which is the moral of the story.
There's nothing wrong in
4 minus 3 will stay is 1 and is not 2. So there's nothing wrong in mathematics. It's too general a statement to give, right? 4 minus 3 is 1, it's not 2. So there are things which are wrong in math. Right? You can't do certain things. लेकिन मैं अब कुछ और ना सोचें. Why have I spent, or if you will, wasted your first few lectures on this stuff? Why do you care about proving algorithms? Who cares? नहीं, आप you may be right जी, लेकिन I'm just asking you to think harder about it जी. You're not wrong, but I'm just saying कि think harder जी.
How these algorithms have changed too much faster.
But मकसद बड़ा है, इवन इससे भी बड़ा मकसद है एक और. मैं मैथमेटिक्स की टोन सेट करना चाह रहा हूँ जी.
Actually, we are trying to learn these algorithms because it's applied in daily life and
डेली लाइफ में किसी को फ़र्क पड़ता है कि लेफ़्ट से राइट से क्या फ़र्क पड़ता है? लोग पूरा पाकिस्तान कैलकुलेट कर रहे हैं इन एल्गोरिथम से एंड नोबडी केयर्स अबाउट दिस. लेकिन दिस समथिंग, व्हाट अबाउट मैथमेटिक्स? और मैथमेटिक्स एजुकेशन में व्हाई इज़ इट इम्पॉर्टेंट जी? बिगर देन दैट, यस, ये भी है. इट्स अ स्मॉल पार्ट, सारी बातें हैं, लेकिन इट्स अ बिगर आंसर टू इट जी. Yeah, you need to think about, yeah, that's the kind of answer that I'm looking for, कि आपको fractions में आपको, so let's move on. मैं अभी थोड़ा सा आगे जाना चाहता हूँ, and this is the kind of questioning that I want. So हमारे पास सारे सवाल, जितना हमने time spend किया, unfortunately the course is on algebra, it's not on how to learn primary mathematics properly, so that's not what the course is, so I can't go too far off. लेकिन आपको ये याद होगा, लेट्स से मैं ये कहता हूँ ये चीज़ -1 times -1 is equal to +1. Hopefully everybody knows
We
this.
are told that when -1 is equal to plus.
Yeah, but you've been told, and you can say what a stupid thing, right? That's what I want you to take away. कि ये क्या पागलपन है? I disagree with this. Do you understand कि आपको मैंने बता दिया, मैं आपका टीचर हूँ, मैंने आपको कहा कि -1 times -1 +1 है, जो कि इस क्लास में नहीं कहेगा उसके मैं नंबर काट लूँगा, तो आपने वो याद कर लिया, राइट? मैं एक और टीचर हूँ, मैं कहता हूँ -1 times -1 is equal to -1. आज से ये रूल है हमारी क्लास का, ठीक है जी? जो नहीं करेगा मैं उसके नंबर काट दूँगा. फिर आप क्या करेंगे? आप -1 times -1 को -1 लिखना शुरू कर देंगे. तो ये मैथमेटिक्स सुना हुआ, राइट? ये तो आप रटा मार रहे हैं. इट्स नॉट मैथमेटिक्स. यू अंडरस्टैंड दैट? सो हमारे पास अब हर चीज़ के लिए वक्त नहीं है. सो दिस इज व्हाट, बट आई वांट यू, देखिए आपकी ये ज़िंदगी का ना ये पहला साल है मैथमेटिक्स पढ़ने का, ना ये आखिरी साल है. यू हैव अ होल लाइफ टाइम टू स्टडी मैथमेटिक्स इफ़ यू विश. अगर मैं आपसे ये कहूँ 3/5, मेरी क्लास में ये रूल होगा, आपको पता होना चाहिए, जिसने इसको वायलेट किया मैं उसके नंबर काट लूँगा. ये मेरी क्लास के रूल्स हैं, आज मैं आपको लिख के बता रहा हूँ, ठीक है जी? जिसने इस तरह ऐड करना पड़ेगा आपको फ्रैक्शंस. ओह सॉरी 12, ये लीजिए, ठीक है, राइट? डू यू एग्री विद दीज रूल्स? ये भी रूल है, ये भी रूल है। क्यों? क्योंकि आपके पहले टीचर ने कहा था, अब नया टीचर आपको ये कह रहा था, ये फॉलो करना शुरू कर दें। ठीक है, बात समझ आ रही है आपको? और ये रूल्स हैं हमारे आज से जिनने इन रूल्स को वायलेट किया उनका अच्छा हशर नहीं होगा। ये मेरे रूल्स हैं, इनको फॉलो कीजिएगा आज से। ठीक है? क्यों? कन्विंस मी कि आई एम रॉन्ग। मैं तो सुनने को तैयार हूँ, मैं आपकी बात सुन रहा हूँ। तो कन्विंस करें, नंबर लाइन यूज़ करके कॉपी लें और मुझे नंबर लाइन पे कन्विंस कर दें कि मैं गलत हूँ। एग्जैक्टली, दैट्स हाउ यू शुड। अगर आपको स्कूलिंग सही हुई है तो आपका ये काम है, आप कहेंगे यस सर एंड वील फॉलो, राइट? बिकॉज यू आर नॉट थिंकिंग। आपको कोई भी कुछ बता देगा, आप बस की बात मान लेंगे और आप कहेंगे यही रूल्स हैं, आज से ये रूल्स हो गए। अगर आपको प्राइमरी स्कूल में ये बता दिया था तो ये हंसने की बात नहीं, ये बड़ी सीरियस है, भी हंसने की बात भी है और अफसोस की बात भी है। अफसोस की बात इसलिए है क्योंकि मैथमेटिक्स इज़ नॉट आर्बिट्ररी। मेरे पास ये ताकत है ही नहीं। दिस इज़ व्हाट आई एम ट्राइंग टू टेल यू कि नोबडी ऑन दिस प्लैनेट हैज़ द पावर टू राइट दीज रूल्स। ओके, ये हमसे बड़े हैं, इंसानों से बड़े रूल्स हैं, हम नहीं इनको चेंज कर सकते, ना मैं कर सकता हूँ ना कोई और चेंज कर सकता है। सो बट अनलेस आपको रीजनिंग ऐसी हो कि आपको, अगर आप कहें कि हम लॉन्ग एडिशन एल्गोरिथम यूँ फॉलो करते हैं, राइट, तो आप कहेंगे नहीं हो सकता ये, फॉर दिस रीज़न। देयर आर रीजन्स बिहाइंड एवरीथिंग, नॉट ऑलमोस्ट एक्सेप्ट फॉर प्लस एंड माइनस एंड अदर आर्बिट्ररी थिंग्स दैट आई टॉक्ड अबाउट। हर चीज़ के पीछे या तो वो हमें क्लियरली बताना पड़ेगा कि इसके पीछे कोई रीज़न नहीं है, प्लस माइनस के पीछे कोई रीज़न नहीं है, कोई हिस्टोरिकल फैक्ट होगा जो हम भूल गए हैं। इट डजंट मैटर कि हम प्लस को प्लस क्यों कहते हैं और माइनस को माइनस क्यों कहते हैं। जी, ये वाला या आई मीन हर एक के हैं, ऑल ऑफ दीज हैव रीजंस। मैं हर एक का रीज़न है कि इट्स अ फॉल्स स्टेटमेंट। ओके, दीज आर फॉल्स स्टेटमेंट्स। को ये ना याद रख ले बाद में कहे कि सर ने कहा था दीज आर फॉल्स स्टेटमेंट्स, के सर ने कहा था कि इस तरह मैथमेटिक्स आज से होगा। इट इज़ नॉट हैपनिंग, दीज आर ऑल फॉल्स स्टेटमेंट्स। लेकिन मैं आपको ये समझाने की कोशिश कर रहा हूँ, दिस इज़ व्हाट यू नीड टू अंडरस्टैंड कि यू कैन कम अप टू मी एंड आस्क मी एनीथिंग कि ये क्यों है, एंड आई एम बाउंड टू ईदर एक्सप्लेन इट टू यू कि जी इसलिए है, एंड देन यू शुड बी कन्विंस्ड। जिस तरह आई एम होपिंग कि यू कैन अंडरस्टैंड द रीज़न वाई द लॉन्ग डिविजन एल्गोरिथम स्टार्ट्स फ्रॉम द लेफ्ट इन जनरल एंड नॉट फ्रॉम द राइट। ओके, दैट्स ए रीज़न। मैंने आपको डंडा मार के ये नहीं कहा कि बेटे लेफ्ट से करना है, अगर लेफ्ट से नहीं करोगे तुम्हारे मैं नंबर काट लूँगा। दैट्स नॉट द वे टू टीच मैथमेटिक्स। ओके, जी, मैं यही आपको बता रहा हूँ कि अब आपको पूरी, मैं आपको तमाम एजुकेशन हम तब्दील नहीं कर सकते, जो पहली से 8वीं तक आपकी हुई है वो तब्दील नहीं हो सकती, लेकिन अब आप उसी मैथमेटिक्स को एक नई निगाह से देख सकते हैं। ओके, आस्क क्वेश्चंस एंड यू विल फाइंड आंसर्स। ओके, आज नहीं मिलेगा अगले साल मिल जाएगा, अगले साल नहीं मिलेगा उससे अगले साल मिल जाएगा, बट देयर आर रीजंस। ओके, सो इफ़ एनीबडी टेल्स यू कि इसी तरह ही होता है तो दैट मीन्स दे आर नॉट टीचिंग यू मैथमेटिक्स। दैट इज़ ऑल, दिस इज़ हाउ इट गोज़। ओके, सो ये मैं आपको बड़ा, हमारे पास ये टाइम नहीं है। आई अनफॉर्चुनेटली आई लव टॉकिंग अबाउट दिस स्टफ बट आई कांट बिकॉज देयर इज़ अ सिलेबस टू कवर। तो मैं हर चीज़ के बारे में ये बात नहीं कर सकता। इज इट क्लियर? हाँ, ये समझ आ रही है आपको बात की? लेकिन आपकी अब ये जिम्मेदारी है कि आप अपनी जर्नी पे, यूर ओल्ड इनफ टू गो ऑन योर ओन जर्नी, स्टार्ट थिंकिंग अबाउट कि ये क्यों होता है। एवरीथिंग, या क्वेश्चन एवरीथिंग, बिकॉज मैथमेटिक्स में कोई डॉगमा नहीं है। That's a harder question to muse about. There's a deep, so I think Ibnul Waqt आप पढ़ रहे हैं, it's something to muse about. So something आपको literature का, और मेरे अभी परव्यू मैथमेटिक्स है तो मैं मैथमेटिक्स तक अपने आप को महदूद रखूँगा। तो question reasons why. सो फॉर एग्जांपल मैं आपको एक छोटा सा होमवर्क देता हूँ। आपने बचपन में कोई बॉडमास रूल, इस तरह का, पता नहीं क्या कहते थे उसे, क्या कहते थे, बॉडमास कहते, पता नहीं जो भी कहते हैं, आई डोंट नो व्हाट इट्स कॉल्ड। आई अपोलोजाइज अगर मैं उल्टी सीधी बात कर रहा हूँ। कोई इस तरह का कोई रूल होता है कि पहले पता नहीं क्या कहते हैं, बॉड ब्रैकेट्स, फिर ये क्या, ऑफ फिर डिवीजन, मल्टीप्लिकेशन, कोई इस तरह की चीज़ें, राइट? ओके, अब सवाल ये पैदा होता है, आप क्या मुझसे पूछेंगे? क्यों? या सो नाउ म्यूज़ अबाउट इट, एंड मे बी अगले हफ्ते में, हम इसी हफ्ते में, यू शुड बी एबल टू स्टार्ट आंसरिंग दिस क्वेश्चन, ओके? कि क्यों है कि पहले ब्रैकेट्स होंगे, फिर ऑफ होगा, फिर डिवीजन होगी, फिर मल्टीप्लिकेशन होगी, फिर ये होगा, फिर वो होगा। अगर मैं चेंज कर दूँ ऑर्डर, फिर क्या फ़र्क पड़ता है? फॉर एग्जांपल, इफ एवरीबडी एग्रीज कि 2 टाइम्स 3 माइनस 6 का मतलब 2 टाइम्स 3 माइनस 6 है। इफ़ एवरीबडी एग्रीज ऑन दिस प्लानट, किसका मतलब ये है, तो मैथमेटिक्स को क्या तकलीफ है? बात समझ रहे हैं, राइट? इंस्टेड ऑफ सेइंग दिस इज 6 माइनस 6, हम ये अस्यूम करते हैं ना कि मल्टीप्लाई फर्स्ट एंड सब्ट्रैक्ट लेटर, दैट्स व्हाट वी डू। बट लेट्स से वी से सब्ट्रैक्ट फर्स्ट एंड मल्टीप्लाई लेटर, फिर क्या हो जाएगा? क्या कोई आफत आ जाएगी? क्या कोई मैथमेटिकल बिल्डिंग गिर जाएगी? क्या होगा? द आंसर इज 2 टाइम्स 3 माइनस 6 विच इज़ -6। तो ये आंसर आ जाएगा, एवरीबडी विल एग्री विद इट। सो व्हाट हैपन्स टू मैथमेटिक्स? मैथमेटिक्स की बिल्डिंग को क्या नुकसान हमने पहुँचा दिया है ये करके? उससे फ़र्क पॉजिटिव 6, 3 माइनस 6 -3 होता है, -3 जी। 2 टाइम्स 3 इज 3 माइनस 6 क्या होता है? मैं इसको यूँ इंटरप्रेट कर रहा हूँ, राइट? ओके, सो मैम आ गई हैं, आई एम गोइंग टू लीव, बंद कर दें। थैंक यू सो मच एंड